Okay, everybody, here's an experiment that we're going to try. It is the summer of 2014, so you who are the class of, I think, 16 or 17, you're going to be the first to try this. What we're going to do is put the entire section of neural communication for medical neurobiology online, and you can master this material at your own pace, either during the summer or during the school year, whenever you like. You're going to let me know how this works for you. So where are we? We're in the basement of the Oriental Institute with a very talented crew of engineers, video and audio engineers, and I will do this in a style where I basically am aiming to try and make each segment about 5 or 6 minutes. You complete the segment, we'll get you, there'll be a quiz that will make sure that you understood what was said in this segment, and then we'll have a test that you can do online to make sure that you got the entire section. Okay, great. So what are we going to do in this? This is neural communication. As you know, one neuron talks to or is talked to by another cell. Sometimes both cells are neurons. Sometimes the postsynaptic cell is not a neuron. It could be a gland or a muscle, and sometimes the presynaptic cell is not a neuron. It could be a sensory cell, such as a hair cell. Okay, regardless, there is a communication between two cells, and one of those cells has to be a neuron. So what we're going to do is, first we're going to figure out what's the language that these neurons are using. And you all know this because you've had physiology. You know that neurons and cells talk in electrical E's, but just to make sure that you completely understand this and the ramifications of electrical language, we're going to go over it briefly. So we'll talk about how a membrane potential is made, and we'll talk about how action potentials are made. How does one neuron accumulate all of its inputs over the entirety of its cell membrane over the course of time, and decide what is the output? What's the output potential going to be, and how is that going to lead to an action potential? We'll talk about neurons that use action potentials and neurons that don't use action potentials. We will talk a lot about how action potentials are conducted, because this is a very important point. Demyelinating diseases are going to be a big piece of your life, not just as a clinician, but as a person. So demyelinating diseases are very common. So we'll talk about myelin and also about conduction in unmyelinated axons. Then we'll talk about neurotransmitter release. This is a very interesting story. It's going to take us into Botox, tetanus toxin, and a few other interesting stories. Then we'll talk about neurotransmitter synthesis, and there is a lot of detail here. A lot of it you've had before. We're going to go over it again and give a little bit more neuro detail, flesh it out in a neuro kind of way, move away from biochemistry and move away from the pharmacology into a more neuro treatment of this topic. And finally, we're going to talk about how does the postsynaptic cell receive a message. And so whatever as this cell is talking, words are coming out, electrical words are coming out. What this cell hears is dependent on what receptors it contains. And so we'll talk about that. And at the end of that, you will understand the framework within which to understand neural communication. Okay, so in the next segment, doesn't matter what I call it now. In the next segment, we are going to talk about membranes.